conditional probability. So let us know what is it. Means probability of an event that depend on another event which happened already. Okay. So this like we need to find probability of an event. So let A and B be two events such that probability, sorry, an event B already happened. I'll explain you, okay? Happened. Then probability of give me a few seconds. I'm just wiping the file. Maybe here it was. Give me a few seconds. Then probability of occurrence of any event A, when B, or we can say event B, I'll explain you, okay? Okay, event B is in relation to A. Is known as, means which known as probability of an occurrence of any event A when event B is in relation to A. And we already explained that B is already happened. Okay. So like probability of any other any event, okay, which is based on to happen on B is said to be conditional probability of A. Okay. Yes, if you have any doubt, then you can ask me, okay? Is known as conditional probability of A. And it is denoted by PA oblique B. Conditional probability of A is denoted by this is equal to cardinal number, or you remember cardinal number of A intersection B
Yes, ma'am.
over cardinal number of B. Or if we want to find for conditional probability of B when A is already happened and it depend on that, then we can find this. Or P probability of B when A is already happened uh, is equal to cardinal number of A intersection B over A cardinal number of B. Or
Ma'am, it will be upon A.
yes, sorry. Yeah, yes, here we will have A because all A is already happened. And we can find in terms of probability also. Probability of A intersection B and also like PB or PA. So let us see. Conditional probability of A is equal to probability of A intersection B over probability of B. Or I'm writing here. One second. Oh, Got it? Either we can find by using cardinal number or we can find by probability. Now let us do examples, okay, to understand this. And one more thing we have in our syllabus, Bayes theorem, conditional probability and Bayes theorem. Conditional probability of A, which is based on on V, we can find by using this formula. Like if they'll give you conditional probability of A with respect, sorry, conditional probability of B based on A, and you have probability of A and B also, then you can use this formula. Or like if we have any three values, can find any fourth one. Okay, because here we have four values, so they can give you any three and can you need to find any one of them. Got it? This is Bayes theorem. Let us check if you have proof. If we have questions, then it is enough. And if you have proof, then okay. So you have anything got from college? Like if they gave you, yeah, we need to prove this. What do you say?
No, ma'am, I've not got it.
Your voice is very slow, so can you type here? Hello? Yeah, tell me.
Yes, ma'am, I've sent you questions.
Okay, okay, you have questions only. So if they gave you only questions, not proof, so we can do question based on this. One check. A fair coin and a fair dice are tossed, and a card is randomly selected from standard deck of 52 playing cards. Determine the probability that the coin, die, and card respectively, okay, a hat, a five, and a king of diamond. So, first of all, we need to find outcomes. Okay. So, let us find first out. Question number B part of 3.9. So, first of all, I'm telling you one example to understand this well, how we know the terms like condition to find conditional probability. Okay. I'm giving you one example, then we'll do our questions. Oh, to start these questions, we need a product addition and product rule also. So after doing that, we will do these questions. Okay. So first I'm going to tell you one example of conditional probability. Then we'll do addition and product rule. So question is, two dice are thrown. Thrown simultaneously, and the sum of numbers obtained is found to be 5. What is the probability that the number 2 has appeared at least once? Means we need to find probability that the number 2 has appeared at least one when we obtain like sum of numbers on both die, okay, is found to be 5. So first of all, let us take even, let A be an event which denotes the combination of two dice in which two appeared at least once. Two appeared at least once. Because we need to find probability of like sum of 7 when sorry, 5 when 2 appeared at least once. So this happened already. That is why what is the probability that okay, what is the probability that the number 2 has appeared at least once? Okay. Sum is already found to be 5. Sorry, I forgot that. This is first condition and this is second. At least once. And B, an event which denotes the combination of the numbers which sum up to 5. So we can uh, represent as A and B. So in A, we will take where we have 2 at least once. Okay. So let us form set. So A is equal to having 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 1 comma 2, 2 3 comma 2, okay, or 4 comma 2, 5 comma 2, and 6 comma 2. Okay, and now let us take event B. where we have sum as 5. 1 comma 4, 2 comma 3, and 3 comma 2, and 4 comma 1. And now let us find intersection A intersection B. How many here we have in common? See, this, this, and this, and this. You got?
Yes, ma'am.
So 2 comma 3 and 3 comma 2. These both outcomes are in common. So now let us find conditional probability of A. Oh, first of all, we can find either we can take cardinal numbers or we can take like probability also. Like we can find probability of A, number of favorable outcomes, entire we have this, and total we have 36. Remember, for 2 dice, we have total 36 outcomes. Okay, so here 3, 6, and 9, 2, 11. So 11 by 36, you got? And PB,
Yes, ma'am.
we have 4, 4 by 36, or 1 by 9. PA intersection B is equal to, this is 2 upon 36, or we can say 1 upon kg. Or to do simple calculation, we can keep them as also. Okay, because further, obviously, denominator here we have 11 by 36 here also and here. So we can keep as such. Now let us find the probability, conditional probability. Since PA of the B means conditional probability of A based on B is equal to PA intersection B over PB. So this is 2 by 36 and PB is 1 by 30. Oh, sorry. 4 by 36. Okay. We can cancel them, and 1 time, 2 times. So is equal to 1 by 2. You got?
Yes, ma'am.
Good. Now let us do addition and multiplication rule. First of all, let us learn addition rule. First case, for mutually exclusive event. For mutually exclusive means there's no common in outcomes of both events. Mm. So as we have taken A and B to events, so addition rule is P. Remember, we have done such kind of formula in cardinality of sets already. And next
Yes,
is,
ma'am.
yeah, because remember this formula N A union B is equal to N A plus N B minus N A intersection B.
Yes, ma'am.
So here, instead of cardinality, we are taking probability because events are mutually exclusive. So there is no common. This will be zero. That is why we have this only. Okay. Now we will do for non-mutually exclusive events. Case two. So if we have a non mutually exclusive, so obviously we will have P A intersection B. Then we will take that together also. P A probability of A plus probability of B minus probability of A intersection B. This this is addition rule. Now let us do multiplication. Is first for independent events. independent event, we have this formula. Probability of A intersection B is equal to probability of A into probability of B. Okay. So when we have independent events, because in independent events, so like no event based on previous one. Okay. And then